This is the screencast for section 1.2, example 7, boundedness. Boundedness describes just what it sounds like. Does the graph have a boundary? And we're talking about a vertical boundary. Does the graph have a vertical boundary preventing the graph going all the way up to infinity or all the way down to infinity? And what combination? So this first example here is called unbounded. There is no boundary preventing it from going up to positive infinity and no boundary preventing it from going down to negative infinity. So there are no bounds. It goes all the way up and down to positive and negative infinity. This graph is bounded below. It has a boundary somewhere below it that prevents it from going down to negative infinity. It does go up to positive infinity though, so it's only bounded below. Bounded above means that it does not go up to positive infinity. It's got a boundary above it, so it has some sort of maximum value it can achieve. It does go down to negative infinity though, so it's just bounded above. Completely bounded functions neither go up to positive infinity nor do they go down to negative infinity. They've got an ultimate high value and an ultimate low value. You don't even have to look at graphs though to determine boundedness. You could look at the range of a function. So if you knew the range of a function, if it doesn't go down to negative infinity, if the range stops at, let's say, -5, you know the graph has a boundary below it. Then if it stops at maybe positive 115, it has a boundary above it too, so you would know it's bounded. Boundedness is asking what infinity does or does not the graph go up or down to. So example 7 is asking us about the boundedness of, first of all, w of x, 3x squared minus 4. I can see that this graph is going to go up to positive infinity. It's a parabola, and it's got a positive a value, so it's face up, open face up. There is a boundary below though. The graph decreases and then goes back up, so it does not go all the way down to negative infinity. So this function is bounded below. As a matter of fact, its range, let's see, the y values or the function starts outputting are at -4 to positive infinity. So I can see that the graph does not go down past -4. It does not go down to negative infinity. Now B, that's a weird looking graph. We can trust the picture of the graph in that this graph will not somewhere out here come back up to infinity or go back down to infinity because the book gave us this example. The book will not mislead you in not showing you an appropriate window to show you all the characteristics of a function. So I'm going to look at this and I see the function goes up and then comes back down, but it does not go up to positive infinity, nor does the graph go down to negative infinity. So this graph is completely bounded. I don't really know what this negative value is or what this positive value is where the graph goes down and up to, but I can find that on my calculator. X divided by, now my denominator needs its own set of parentheses, 1 plus x squared. And then I'm going to change my window to exactly what the calculator wants it to be, -8, or what the book wants it to be. -8, +8 for my x min and x max. And then -1 and +1 for my y min, y max. So it looks very similar. I can go second calc. And then number 4 is this maximum up here. So I'm going to go to the left of the maximum. Then I'm going to go to the right of the maximum. And then I'm going to go right on top of it. So that point up there is 1 comma, looks like 1/2. Then I'm going to try and find the minimum, second calc min. So I'm going to go left of the minimum, enter. It's asking me for the right bound, so I'm going to go to the right of the minimum, enter. And then right on top of the minimum, enter. -1, -1/2. So I can tell you that my range for this function is -1/2 to +1/2. It goes down as far as -1/2 and goes up as high as +1/2, but it doesn't go any further than either one of those. It does actually hit -1/2 and +1/2, so I'm going to put -1/2 with brackets and positive 1/2 with brackets because we do land on those two values. The now try problem number 37 says determine whether the function is bounded above, bounded below, or bounded on its domain. So first of all, y equals 2 to the x. I graphed that in my calculator, so you might already say, oh, I know this, I know this, I know this. Okay, but let's look at it a little bit closer. Y equals 2 to the x. Now, let's look at some extremes. What about f of 100? That's 2 to the 100th power. So that's going to be like 2 times 2 times 2 times 2. It's going to be like a really, really, really large number. So you can see that that's approaching infinity to the right. But now to the left, maybe f of negative 100 is going to be 2 to the negative 100. So that's going to be like 1 over 2 to the 100, so 1 over this really, really, really large number. If you take 1 and divide it by a really large number, you're going to get something very close to 0. So I can see that my range for this graph is going to be 0, not including 0, though we don't actually get there. And then we go all the way up to positive infinity. So by looking at that range and by looking at the graph, you can see that it's bounded below.